Okay, so this video is about rectangles and their properties. The first thing is all the properties of parallelograms. Still hold true, which we learned about in class 35. The one this video is about is all four angles are congruent. This means that they are all right angles. Okay, so this one is working with, we're going to have a few examples on this. We're going to first do example number 2 for number 1. So reason number 1, we have angle BCA is equal to 78 degrees. BCA is this angle right here in yellow. Nope, not BCA in angle A. Let's try that again, Palmer. BCA is right here. Okay, this angle right there. And then we have the angle of DAC, and they want us to find this angle here in orange. Okay, so rectangles are parallelograms. So with a rectangle, parallelogram has two pairs of opposite sides being parallel. So the opposite side that's parallel here are these two. I just drew my arrows in the opposite ways. Let's try that one again. Just make it a little bit prettier here. We'll just go with it. And so, this is a transversal that cuts those two parallel lines. This angle here is 78 degrees. We're using reason 1 because we're using opposite sides are parallel. Measure of angle BCA is equal to measure of angle DAC. So 78 degrees to substitute in equals measure of angle DAC. And if you want, you can flip this around to be measure of angle DAC equals 78 degrees. And once again, that is because of a rectangle being a parallelogram where opposite sides are parallel, transversal comes through, alternate interior angles theorem allows us to say that the measure of angle BCA is congruent to angle DAC, so their measurements are equal. Now, going on to all four angles are congruent, we're going to talk about here building that out. So, on reason number 2, all four angles are congruent, meaning that they're all right angles, meaning that we have a right angle that is 90 degrees at every corner. Find the measure of angle BAC. So we want to find the measure of angle BAC, which I will highlight, or find the measure of angle ACB, but I'm going to highlight this out here. For BAC, we know this angle here is 27 degrees. Okay, find the measure of angle ACB. So this is the angle in question of angle ACB. So with this being a parallelogram, first and foremost, opposite sides are parallel. So if this is 27 degrees, this is also 27 degrees. So I'm using that idea of all properties of parallelograms hold true in rectangles, but then I know that this angle of BCD is 90 degrees. So, reason number 2, all angles 90 degrees. So since these angles are the same, the measure of angle BAC is also equal to measure of angle DCA, which is what I'm going to use here. Since they are equal to each other, measure of angle BAC is equal to, plus measure of angle BCA. Yeah, we'll go BCA. I apologize, we will not go with ACB based on how the problem is written. ACB equals 90. So this would be 27 plus measure of angle ACB equals 90. Measure of angle ACB equals 63 degrees. All right.